All right, welcome to Unit 11-2. This time we're going to be solving, where's my pen? Solving our trigonometric equations. So now we're going to throw an equal sign in here. Now, a couple of things to just note before we start. First of all, you can have several solutions. When we say several, it used to be that we're thinking one or two, but no, we could have three or four, or actually you can have an infinitely amount of solutions. Most of these in this assignment are going to have 1, 2, 3, or 4. But what you have to key in on is what we call the defined interval, because remember our unit circle, or any trigonometric equation or function is what we call periodic. Remember, it kind of just repeats itself. It kind of keeps going back. So there's lots of angles that have a y value of 1, or lots of angles that have an x value of -1/2. So we'd have to look at the interval to be able to give our solutions here. So first up, when we look at this, we're isolating or getting the trigonometric function all by itself. So in this case, sine of theta is my trigonometric function. Over here, it'd be tangent of theta. You just have to look to see what trig function you're looking at. And then we'll talk about extraneous solutions in a little while. So let's look down here. And the very first step again is that you're going to get this sine of theta all by itself. So notice this 6 is multiplied. We'll have to undo that, but we like to undo this subtraction first. So this 3 is just subtracted. So we're going to say, let's use our properties of equality and just add 3 to both sides. We're still equal. So now we have 6 times the sine of theta is equal to a positive 3. Okay, now we're going to undo that 6 right there. So we're going to say, okay, I know that if I divide by 6, that undoes my multiplication. 6 divided by 6 is just 1 sine of theta. That's equal to 3/6. I'm actually going to simplify that and write that as 1/2. All right, so that is the first step. Now what we're going to do is we're going to look at our interval. So notice this is the interval that they gave us right after the problem. They said we're looking for all of the angles, this theta is an angle, in between 0 and 360 that have the sine equal to 1/2. So we're going to pull up our unit circle. You guys just probably want to have this in front of you. I am going to see, there it goes, look at magic, it just appears. We're going to pull up that unit circle right here. So again, what you want, you hopefully have this on your unit circle. Let's rewrite this, but our unit circle, we know that our sine of theta is equal to our y value right here. We also had the cosine of theta is equal to x, and the tangent of theta is equal to y over x. So hopefully you have that. If not, write that on your unit circle. We're still going to be using this. Okay, so now what we're going to do is we're going to look between 0 and 360. Here's 0 and 360. So anywhere on this unit circle, we're looking to see where the sine or the y value is positive 1/2. Okay, so I'm just looking here at all my y's. Oh, look, there is a positive 1/2. Okay, also you want to look out for one more thing. Where's my clicker? You want to, undo. So we're going to move this just a little bit because our solutions should be in degrees. See that right there? They want our solutions to be in degrees. So we're going to say this 1/2 right there, that went with our 30 degrees. So 30 degrees is a solution. Don't stop there. Remember though, you can have multiple answers. So we're going to see if there's any other 1/2s around my unit circle here. Y values. There is another positive 1/2. So we're going to say it's also at 150 degrees. Keep looking. There's a negative 1/2 that doesn't count. Here's another negative 1/2 that doesn't count. So those are my only 2 answers, and we're going to circle that as our answer right there. Okay. All right, we're going to erase all this stuff here. You're just going to have to remember the sine is y, cosine is x, and your tangent is y over x. All right, so now what we're going to do is we're going to do one more thing. We're going to move this over here, and we're going to look at this next example. All right, so we're going to solve for our trig ratio right there. We're going to solve for the tangent of theta. So the only thing we have to do here is just divide by that -2. It's multiplied by -2, so we're going to divide by -2. And we've got that the tangent of theta is equal to, now these 2's can divide. 2 divided by 2 is just 1. However, you've got a negative right there. So it'll just go to a negative square root of 3. All right, so now look at the interval right here. We're only looking between 180 degrees and 360 degrees. So here's my 180, here's my 360. So we're just looking at the bottom of our unit circle right here. Now, hopefully you guys wrote these on. If you didn't, write them down really quickly, because we went through and divided all of these lovely tangents, because our tangent, remember, is our y divided by x. So the tangent right here, negative 1/2 divided by a negative square root of 3 over 2, that went to negative square root of, not negative, it's positive, square root of 3 over 3. This went to 1, this went to square root of 3. So notice that they're all positive over here. But in this quadrant right here, we've got a negative square root of 3 right here. That'll be a negative 1. This is a negative root 3 over 3. So if you have not written those down, you probably want to, so you don't have to go through and solve them every time. That was, if you need to remember how to solve those, that was in last unit. Look at the videos for unit 10. But here's my tangent of negative square root of 3. Okay, so that means that the angle that I'm looking for here is just that 300-degree angle. And you're done with that one. All right, we'll try the radian examples in our next video.